Imagine gazing out your window and seeing the summit of a Martian volcano towering above a sea of clouds, just as astronauts do from the International Space Station, but on Mars. This breathtaking scene was captured by NASA's aging Mars Odyssey orbiter, revealing Mars in a way humans have never seen before. But what if I told you this historic mission, which continues to deliver groundbreaking discoveries, is now at risk of being shut down, right when it might change everything we think we know about the red planet? To understand why this is such a big deal, let's rewind. Mars Odyssey launched in the early 2000s, and it is now the longest-running spacecraft orbiting another planet. For over 2 decades, it has delivered a treasure trove of information about Martian geology, weather, and even potential resources for future human explorers. In just the past couple of years, Odyssey shifted its gaze from Mars's surface to its horizon. By rotating 90 degrees in orbit, Odyssey's camera has started capturing spectacular images of Mars's atmosphere, showing layers of dust and clouds, and even revealing how they change with the seasons. Planetary scientist Dr. Emily Carter puts it bluntly: the Odyssey image is a stark reminder that even veteran missions can yield novel discoveries. The subtle atmospheric details are invaluable for refining our climate models. The latest images zeroed in on Arsia Mons, a colossal volcano standing about 20 kilometers high, twice as tall as Earth's mighty Mauna Loa. This behemoth isn't just a geological wonder. Its high altitude and equatorial location make it a hotspot for weather phenomena, with water ice clouds forming around its slopes every Martian morning. Scientists are now realizing those clouds aren't made just from carbon dioxide ice, as once thought, but are shaped by a unique blend of orographic lifting and possibly subsurface water ice. But Arsia Mons is more than just a showpiece. It is a key to Martian mysteries. Recurring slope lineae, dark streaks that appear and fade on its caldera, may hint at the presence of transient liquid water, a potential signpost for microbial life. Themis, Odyssey's infrared camera, has also detected patches of andesitic rock here, challenging long-held beliefs about how Martian volcanoes evolved. According to Dr. Ken Farley of Caltech, the potential for andesitic compositions on Arsia Mons challenges our understanding of Martian magma evolution. It highlights the need for in-situ analysis to confirm these orbital observations. International collaboration has been intensifying too. The European Space Agency's Mars Express mission is teaming up with Odyssey, using the Omega spectrometer to match data with Themis images. This partnership is unlocking new details about how volcanoes and atmosphere interact, giving us a more complete picture of Mars's changing climate. And yet, just as these discoveries are piling up, Mars Odyssey is facing an existential threat. The budget proposed for the next fiscal year from the White House would halt funding for this incredibly cost-effective mission. If that happens, the continuity of this unique Martian perspective and all the potential breakthroughs still waiting to be found could be lost. So here is the dilemma. Should humanity pull the plug on its oldest Mars explorer, right when it is on the verge of rewriting the story of Martian weather, geology, and even the search for life? Or is this the moment to double down, invest, and unlock the secrets that could shape the future of Mars missions, and maybe, one day, human settlement? But what happens next if Mars Odyssey goes dark just as its discoveries hit a new peak? Imagine for a moment a future where those breathtaking images of Arsia Mons are the final transmission from a probe that has circled Mars for more than 2 decades. In that scenario, the science comes to an abrupt halt. The recurring slope lineae, those mysterious dark streaks that may hint at seasonal flows of salty water, remain unexplored. The radical possibility of andesitic rocks, which could rewrite our understanding of Martian volcanism, stays just that, a possibility, not a fact. And the international synergy, with data from Odyssey's Themis camera being matched to Europe's Mars Express, loses momentum. It is not just a missed opportunity for NASA, but for all of humanity's quest to understand our place in the cosmos. On the other hand, if funding is restored and Odyssey continues, the path forward branches into thrilling new territory. With each orbit, more is revealed. Atmospheric models become sharper, helping future missions dodge deadly dust storms. The detailed study of cloud formation and subsurface ice could directly support new missions, like the proposed Arsia Mons Glacial Ice Explorer, a robotic lander armed with radar, aiming to probe the secrets locked beneath Martian ice. If that mission is ever launched, perhaps in the early part of the next decade, it could reveal whether the volcano hides reservoirs of water or even clues to ancient Martian life. As Dr. Emily Carter puts it, veteran missions like Odyssey still have the power to change everything we think we know about Mars. The stakes extend far beyond the red planet. This work is essential for anyone dreaming of a future where humans set foot on Mars. Every layer of cloud mapped, every patch of ice detected, becomes a lifeline for future explorers. Water on Mars means drinking supplies, breathable oxygen, and even the fuel to launch return rockets. Imagine a settlement at the base of Arsia Mons, powered by resources mapped today by Odyssey's tired but still sharp-eyed instruments. But if we let these eyes close, future missions must proceed with greater risk and less knowledge, a gamble with lives and billions of dollars at stake. What does it all mean for us, watching from Earth? It is a reminder that scientific progress is often fragile, hanging in the balance of policy and public will. Today's discoveries on another world can drive tomorrow's innovations here at home. The algorithms used to process Mars Odyssey's images, for example, are being adapted to improve weather prediction and resource mapping right here on Earth. The international spirit of collaboration, NASA, ESA, universities across continents, sets a model for tackling challenges like climate change and planetary protection. And most importantly, it demonstrates that even modest investments can yield knowledge whose value is immeasurable. So, will humanity invest in keeping Mars Odyssey alive, or let it fade away just as it is poised to unlock Mars' greatest secrets? The answer, at least for now, is that the conversation is not over. Public interest and scientific advocacy have already bought Odyssey precious time in the past. If enough people see the value, the mission could yet be extended, setting the stage for more daring explorations, including that first robotic ice explorer at Arsia Mons. Dr. Sanjay Patel perhaps said it best. If recurring slope linii really are signs of liquid water, we could be looking at the most promising site for life beyond Earth. Shutting Odyssey down now would be like closing the book just as the plot thickens. Here's a secret. Some of the most transformative missions in space history were saved at the 11th hour by public outcry and scientific perseverance. The fate of Mars Odyssey may well rest in the hands of those who care enough to speak up. If you believe that exploring Mars matters, not just for scientists, but for the future of humanity, make your voice heard. Support the missions, share the stories, and help write the next chapter in our search for life on Mars. Thanks for watching. If you want to stay updated on the latest discoveries from Mars and the inside story of how global science is made, don't forget to subscribe, leave a comment, and share this video. The Red Planet's next big secret may depend